Hey everyone, welcome to our Carbon Conundrum episode. Despite lots of hard work to make our ITS installations more energy efficient, there's still a long way to go in order to meet the requirements of carbon neutral net zero requirements. So we're going to look at some of the next steps that we might want to take in order to achieve this. I'm Alistair and this is ITS Now. Over the past decade, technology manufacturers have made great strides in reducing the energy consumption of ITS equipment. The switch to modern electronics and LEDs has had a transformative impact on electrical consumption of installations, with many types achieving at least 80% savings when compared to traditional equipment. This process is also ongoing. As an example, with currently emerging LED products looking to achieve a 1 watt traffic signal aspect compared to the 50 watt for traditional halogen lamps, or even around 10 watts for many current LED products. However, in the coming few years, reliance on electrical savings will not be sufficient in its own right. Steve Elderkin, the Director of Environmental Sustainability at National Highways, recently said, "Achieving net zero will be part of everyone's role." So we will need to continue to reduce the environmental impact of our installations to a level that aligns with the goals set in the COP26 Glasgow Climate Pact in November 2021. And although the net zero requirement is not mandated until 2050, many organisations are either already carbon neutral or working actively towards this, with a view to attain net zero by 2040, such as National Highways Maintenance and Construction Goal. This also needs to be viewed in the context of the fact that road transport as a whole accounts for 10% of global greenhouse gas emissions, and the total emissions are rising faster than any other sector. Because of this, the transition to zero-emission vehicles is of vital importance, but intelligent transport systems infrastructure cannot rely on this to offset overall savings in the sector. The ITS element also needs to step up to this challenge. Infrastructure as a whole is responsible for a staggering 53% of the world's greenhouse gas emissions, of which nearly 20% is attributed to the embedded emissions from infrastructure, i.e. the manufacturing, construction, and life cycle management of infrastructure assets. We've seen that significant savings have already been and continue to be made on the operational side of our sector, but the embedded carbon caused by the civils construction and the manufacture installation of equipment needs to be addressed. As an illustration of the impact that construction has, if the cement industry is compared against national emissions, it will be the third largest global emitter of carbon behind China and the United States. Unfortunately, though, with the pace of technology change which is anticipated for the sector over the coming decades, the certainty the industry had for planning infrastructure requirements is now far more problematic, leaving it difficult to establish a reliable roadmap for equipment requirements in coming years. This stems from the anticipated benefits that both connected and then automated vehicles will provide. Because of this, the ability to build in longevity into future-proof installations is now more difficult to justify because of the long-term uncertainty about the requirements for equipment to be installed in our roadsides. I don't think we need to worry about flying cars just yet, though. The paradox to this, though, is the growing anticipation and reliance on technology to overcome issues such as capacity constraints, to provide alternative solutions to the construction of new features, such as new or widened roads. To facilitate achieving carbon savings, a carbon reduction hierarchy should be adopted. This provides a framework around which both strategic and specific decisions can be made. So, build nothing. Therefore, the starting point to reduce carbon begins with assessing if new infrastructure is actually required. Could the operation of existing assets be optimized or repurposed to achieve the desired outcomes instead of building a new installation? Build less. If we do need to construct something, can we rationalize it to reduce the impact? As an example for traffic signals, this will look to justify the requirements for each new pole and cabinet. This will need to balance user safety of the finished installation, but by not ending up with a surfeit of equipment, this obviously also provides benefits of minimizing street furniture clutter. So a very simplistic example is whether you need 2 poles or 4 poles for a crossing installation. Build clever. One of the biggest areas for improvements in infrastructure construction is the adoption of circular economy techniques within the material supply chain. Traditionally, the linear economy would extract natural resources, turn these into a product, and then discard them at the end of their life. We're not going to get away from using materials like concrete, but by using non-virgin materials, preferably renewable, in these, results in considerable carbon savings. Build efficiently. Wastage of materials and resources is an endemic problem when constructing infrastructure. It is still common for a large proportion of brought-in materials to be wasted and not used in the finished asset. Although the traffic signal sector was an early adopter of using modular and factory-produced equipment, this is an area where more thought will need to be applied. As an example, precast concrete products can provide confidence in repeatable quality owing to their being produced in a controlled factory environment, achieving a huge reduction in waste. We need to consider how the lifespan of existing infrastructure can be extended when equipment updates and replacements are required. Because of the earlier foresight of practitioners across the industry, most traffic signal installations use fully ducted systems with pole retention sockets, so signals renewals can usually make use of these with minimal need for replacement. Specifying low-carbon products should be integrated into projects from the very start, rather than being afterthoughts. Alternative concrete mixes are becoming more readily available. Using recycled aggregates and alternatives to Portland cement, it is possible to produce concrete with 80% lower embodied carbon compared against traditional specifications. Alternatives to traditional steel poles can offer much longer life expectancies at moderate additional costs. For example, expected lifespans of 50 years are often claimed for aluminium poles. Although aluminium made from bauxite is much more energy intensive than steel production, many aluminium products are actually made from recycled materials, which is far more energy efficient. Or maybe we could plant trees where we want signals and signs in a few years' time. Designers will need to think about how they design so that at the end of life, installations are easy to disassemble and demolish, facilitating efficient recycling of materials. Polypropylene chamber boxes are recyclable, but this is very difficult if they're encased in concrete. Also, where concrete products are used, these often incorporate lifting eyes, so these could also be used to remove them, allowing the possibility for these products to be used again elsewhere, or to be efficiently recycled at a specialist centre. It's expected that technologies will evolve which will provide even greater emissions reductions over coming years. As this sector matures, leaner construction techniques which reduce waste, new end-of-life materials and waste management processes will make use of more digital solutions. But we can't just sit back and wait for these to come.
Please subscribe to keep up to date with ITS Now.
The replacement of diesel-powered plants and generators will also make a contribution to reducing the footprint of our construction projects, whilst also reducing noise, nuisance and pollution to nearby residents. In order to quantify and report the success of carbon reductions, the use of a carbon calculator will allow designers to make informed decisions for their projects. The direct integration with BIM software and bill of quantities enable efficient calculations to be undertaken up to 90% faster than using manual methods. For ITS to achieve further improvements, the dilemma, the conundrum, is to balance our current requirements against the fact that due to technology evolution, many types of new installations may become obsolete before they are expected to become life expired. This is also set against the issues raised by a lack of investment over the past decade that leaves a lot of areas in a very poor condition. So it will take some imagination and engineering pragmatism to reach a point where connected vehicles might start to mean that there is more certainty over the required provision of roadside ITS infrastructure. Right, as ever, could I ask you to please subscribe to our channel? It does make a huge difference to us to be able to bring you these episodes, and a big thank you if you have subscribed. Also, if you work for a company that would like to be involved in one of our Technology Insight series, please feel free to get in contact. We've a number of these coming up, so look out for those. Until then, thanks for watching. See you next time.